Now, what Gryff is trying to do is it's trying to take this ABD protocol and EPaxos and put them in the same system. With ABD, the authors try to achieve low tail latency, especially for the read operations. And with EPaxos, they try to provide a little bit more functionality than is possible with ABD. Right, so in particular, ABD doesn't allow for this transaction-like operation. So you cannot have let's say, a read modify write operation. So where in just a single operation, you read the state of the register or variable, whatever, and based on this read, you modify it. Let's say you, I don't know, increment it by 1, and then you write it back. So ABD cannot perform that, but with the EPaxos, you can actually do this more complicated commands. So yeah, but if we take these two protocols, of course, the problem becomes how do you actually order these two types of operations? So Gryff with its ABD can only perform reads and writes, just a regular put and get operation. And with EPaxos, it only does this read modified write kind of small transactional operations, right? How do you order them with respect to each other is the bigger problem that Gryff tries to solve. As I said, the initial premise is we want to have a strongly consistent storage system. So they need to make sure that the order is linearizable, which means it adheres to the real-time ordering of events. And the solution for their ordering problem is something that the authors call car stems, which I believe stand for consensus after read, something like that. Anyway, the car stamp is a tuple that brings together the ABD's versioning, the ABD's write operation versioning, and the logical timestamp for each read modify write operation. So it's a tuple of ABD logical timestamp, process ID to resolve the conflict in ABD logical timestamps, and read modify write logical timestamp. So yeah, ABD logical timestamps, they are only used by the ABD protocol. So on every ABD write, this logical timestamp is going to be incremented. The process ID, as I mentioned, resolves the conflicts in case two coordinators try to write the same ABD logical timestamp. And read modify write logical timestamps are this EPaxos thing, or the thing that's used in EPaxos for ordering of read modify writes. Now, Gryff actually doesn't try to attempt to order all read modify write operations because it would be wasteful and it's unnecessary, right? So the only thing that we care about is ordering the read modify write operations that essentially try to update the last version of ABD write, right? So the way I think about this is when so ABD writes are they provide this base version of the register. And then if you have more than one read modify write operation going on concurrently, this is why you need EPaxos to order them with respect to each other. But as soon as the next ABD write comes in, that ordering doesn't really matter anymore because the ABD write is going to override the register anyway. So this allows Gryff to kind of compartmentalize the ordering of read modified write operations with respect to their ABD version. So the graph that is going to be used for ordering these read modified write operations is smaller. So that should help EPaxos performance with conflicts and things like that. Overall, ideally, it should give better performance than EPaxos on these read modified write operations. Obviously, the authors had to make some changes to make sure that EPaxos can work with these car stamps. the most important change, the most obvious change is now we have to have the ordering only for each of these base versions of ABD writes. So we don't order everything, every read, modify, write operation with respect to each other. And another very important change to EPaxos is how the protocol executes the operations. Because ABD protocol requires on its write path, it requires the majority of nodes to perform this write. And when the node performs writes in ABD, they actually apply them to this shared register, so they execute the operation. The same has to happen in EPaxos, and this execution has to happen on the quorum, on the majority of nodes in the cluster, so that the next ABD read, when it comes, it doesn't regress to a previous version. Yeah, so in a nutshell, this is what Gryff is. It's ABD protocol with the sprinkled EPaxos for the read, modified, write operations that are joined by these core stems. Now, when the authors did their evaluation, obviously they focused on the wide area network because that was the problem they tried to solve. And they focused on the latency of operations. Yeah.
Maybe let's take a break, and I can ask the participants to write in the chat if they have, again, maybe basic question to summarize this or clarify something that's missing before we go on to the evaluation part. We can take a couple minutes to see if somebody has a clarification question about
the evaluation is just 2 slides. I can finish it up really quickly, but yeah. So yeah, I guess any questions? If there are any questions, we can use the chat or we can use the Google Doc that we shared earlier.
Andrew asked, why do we care about read, modify writes on old writes if their result is overwritten anyway? I think this is one of the discussion topics that we will pick up on later. But
yeah. It's actually very interesting, right? Because the question really boils down to why do we want read, modify, write operations combined with this ABD writes and puts in the first place? The problem is ABD operations, they're not transactional in nature, right? So they just blindly overwriting things without checking if there are anything that is conflicting this operation, because the ABD protocol doesn't allow for that. So it is possible that you perform the read, modify, write operation, and if your application then does the regular write, this concurrent write with this read, modify, write operation may possibly interfere and essentially make the read, modify, write obsolete right away. But as I said, this read, modify, writes are really the sprinkles on top, the functionality that may exist if you want to take advantage of it and build something of more transactional nature, I suppose. But yeah, this is definitely a topic for further discussion. Any other questions?
I think let's move on with the evaluation.
Yeah.
Oh, one more. Alex is asking, why is n is equal to 5 less optimal for Gryff than EPaxos? Okay, this is about evaluation. Maybe.
Yeah. Well, yeah. I'll get to it in a bit. Yeah, maybe I shouldn't say it's a best case, but yeah. Anyway, the point, I guess, in the evaluation is we are trying to make the better tail latency for operations, especially for the read operations. And that seems to be working just fine. If you look at the figure 8a, the read latency the tail latency and is much smaller than you would observe in multi-Paxos and EPaxos protocols. Now, for the writes and read-modify writes operations on figure B and C, that's not really necessarily the case, right? So the tail latency of Gryff actually goes higher. It still beats multi-Paxos for writes as far as the tail latency concerns, but it's definitely doesn't have as big of an advantage in tail latency on writes as on read. And the main reason, of course, is because the write protocol always requires 2 RTTs, whereas the read protocol, actually read protocol with n equals to 3 in ABD, the authors of the paper claim that they can do it in 1 RTT all the time. And this is kind of why I say it's the best case scenario for Gryff, at least when it comes to writes. So yeah, and that definitely gives them advantage in the tail latency because if you do it in 1 RTT. Figure 9 shows the results when the EPaxos has 5 nodes instead of 3, and we can see that actually on the reads, its tail latency is not as great. That's going to be the figure 9a. I believe this figure actually shows that Gryff, like maximum latency, is higher than for the reads, is higher than the one for multi-Paxos. And similar for the writes. The Gryff writes are not as good as both EPaxos and multi-Paxos. Yeah, finally, when authors did the evaluation on the throughput with n equal 3, yeah, I believe this graph is n equal 3 on 3 nodes, we can see that Gryff, while it outperforms multi-Paxos in terms of the maximum throughput it can sustain, it actually falls short compared to EPaxos, the blue line. Yeah, just looking at these performance results, I kind of have a very mixed feelings about it because it doesn't seem to perform that much better than multi-Paxos or EPaxos. So yeah, this is where I probably want to conclude this short presentation, and we would likely move to the discussion section. But in short, Gryff is the hybrid of the ABD and EPaxos. The protocols, the ABD and EPaxos, they work mostly independently, but they're tied up together by the car stems. And a lot of the evaluation actually focuses on the fact that ABD performs better for reads when we have a small number of participants. So I guess now would be a good time for questions.
So I unmuted everyone, but if you like, you can keep yourself muted, unmute yourself to ask a question. I don't know how Zoom works that well, but I guess with 20 people, I think the chances of collision is not that bad. Or I guess there are features to raise hands or something. If I figure out, I'll tell you about it, but go for it. If you have questions, comments, we can have, I think 20 minutes of general discussion. So we identify maybe 3-4 deep discussion topics, and I can put you in breakout rooms so that you can collaborate over Google Docs to, brainstorm about feature directions, about resolving whatever specific question your room has. Oh, I'm not muted now, right? Okay, good. So that's it. So let's have general discussion for 15-20 minutes. And yes, Bharat says that we can start with the doc questions, and maybe that will produce more offshoots. Alexei, you are sharing your screen. Can you go to the Google Docs questions, and let's try to answer it all together.
Yeah, let's see. Let me find the Google Docs. Yeah, I saw someone raise a hand. I guess don't be afraid to speak up too.
Alt Y, okay. Yep, we can see the Google Doc now.
Yeah. Questions. Cassandra implements read-write registers via ABD-like algorithm and also has EPaxos for compare and set transactions. Cassandra can be used to implement read modify write, I think, right? Anyways, compare and set is likely the same performance as read modify write instructions. So how would Gryff performance compare it to a similar Cassandra deployment? Well, for one, yeah, it's a really good point that Cassandra is actually very similar protocol. I think by default, yeah, Cassandra as a database is loosely based on Amazon's Dynamo paper, but the actual protocol, the default protocol, is very ABD-like, with the clients contacts in the node is serving as the coordinator and writes in, and they override the register in place. The read protocol, when Cassandra is considered for strongly configured for strong consistency, it has the similar two phases. It has the read recovery that has to happen before the information is returned back to the client. So it is very similar to ABD in nature, aside from the hash ring topology of nodes and things like that. And it does have the compare and set transactions which are backed by EPaxos. So in a sense, it is a hybrid that is very similar. Obviously, compare and set transactions in Cassandra are slightly more limited in semantics, I suppose, because all you can do is say, update the value of row when something is true, when the cell is true or whatnot. So yeah, as far as performance, yeah, I don't know. I think it would be very similar, but yeah, performance-wise, I'm not sure. I mean,
okay,
it will depend on the implementation.
Let's ask if anybody has anything to add or for this question.
Yeah, I'm not sure if people are muted or people are just shy.
They can unmute themselves, or if you like, keep yourself muted. But if you keep the spacebar pressed, you are temporarily unmuted and you can make a. Let's try to see if you can unmute yourself. Maybe one person does this, so we answer.
The pains of technology. Murat, are you sure you didn't lock everyone on mute?
Okay, I think I'm unmuted now.
Cool, yeah.
I guess the only question I really have is it would be helpful to have a concrete real world sort of example, like I don't know, like a bank account or like, yeah, like the social media example of like a sequence of read, write, modifies or reads and writes of like a real value.
Yeah, that's an excellent question. And to be honest, I don't have an answer. If I can continue drawing the parallels with Cassandra, right? In Cassandra, for example, once you start using compare and set transactions, and then you revert back to the normal operations, you have this chance of losing the, because the regular operations are unchecked, right? They're not transactional in nature, so the concurrent operation can override your, compare and set, counter, or whatever. So with the same as read modified writes, if I have a counter, so my read modified write operation would be read the register, incremented by 1, write it back. So I'm performing these 3 things atomically, right? And let's say I do it against the base version 1. So my base version, the ABD version, is not going to change. I increment the counter, and I try to write back. I do this quorum execution. And at the same time, the ABD write may come in, and it may try to write with version 2. And this will be the replace that's completely unchecked with my read modified write operation, right? So there is no, at least as far as I understand, there is no good way to, in Gryff kind of system, a good way to check this, because ABD is not transactional in nature. It's just going to overwrite this higher value. So your counter update just got lost by the virtue of this non-transactional replace being performed against the store. So as far as like the real application, that is going to use both the regular writes and reads and the read modified writes on the same piece of data, on the same register. It's kind of difficult for me to think of one, to be honest.
But it's not quite that. I had the same objection in the Hermes paper to this. Mm-hmm. What they're implementing is something that allows a fully interactive transaction against a single key. And the thing to compare against here would be, what if you had a write operation in ABD that instead of doing a write was just an increment? And so you're not serializing a write into, or like ordering a write into your write stream. You do some writes, and then you have a increment operation that when you go to apply that to disk, you do the read, the increment, and the write. And then it seems like you also don't need EPaxos in this case, because as long as like ABD is ordering things for you.
Well, here's the thing. ABD can order the things, but ABD cannot multi-writer ABD, right? When you don't have a single leader, you don't have a good way to control things like reading the value and then performing something on this value and then writing back.
Right, but it's specifically if what you want to do is read the value and then do some arbitrary operation against it and then write it back. That's
going to be the read modified write operation.
Yes, but and that's you have to more general than what you can do with just operations. Like if you're willing to hard code into your operation that like this is an increment operation, then you don't need something that's like a fully general load linked store conditional operation. You only need something that's explicitly hard coded as an increment. Like this is the difference between Cassandra having lightweight transactions and counter tables.
Yeah, and this increment operation, right? It would be a read modified write. So at the application level, you have to take some precautions to make sure that you can complete this read modified write before you can start running unchecked replaces.
Right. So I guess the thing is, you need to order them in a, they call it unstable order in this paper. I think section 2 talks about it, and section 2 says that even if you define an increase operation like that, right, it's essentially a read modify write operation, and that requires a unstable order, meaning that you cannot have two concurrent increments to the same key, which basically defaults to having consensus.
You can have two concurrent increments with read, modify, write. It's just that once you have this arbitrary number of concurrent read, modify, writes, if you have a replace operation, the put operation, that may screw things up for you. That's what I think.
Right. So you can have them concurrent, like in EPaxos, but everybody needs to have consensus on how to order them the same way. But maybe, yeah, you are right. Maybe for things like commutative things like +1, you can use less relaxed consistency, such as CRT or eventual consistency, and make this better, right? So for commutative operations, there is room for improvement. But otherwise, if it is more general, like read, modify, write, you need to have consensus by all the replicas on the correct ordering, or one ordering of the same ordering of them at all times.
From chat, a possible application, you write a social media post and want to edit it. The initial post would be an ABD write, then all edits would be read modified writes. However, further edits reveal your opinion was just bad and never should have been posted in the first place, so you delete it. I guess the delete would be another ABD write.
I think in general, I haven't seen social media applications require too much of strong consistency. Yes, that's the paper uses that as a potential application. I think in some place it mentions it, or in the talk, NSDI talk, the presenter mentions that the social media is an application that this could be deployed. But I think social media people have different ways of doing it, the same thing without requiring strong consistency.
Okay, so maybe we should go back to the paper questions for a little bit. Why is the relation done only with wide area network? Yeah, I think I actually answered it in a doc. They do have the local area network experiments that the throughput figure is local, but another thing about the wide area network, right, is when you want to look at the latency in the wide area network, the latency is going to be more affected by the distances between the regions, between the nodes in this configuration, right? So if in local area network, if you try to look at read latency or write latency, all of the nodes are more or less the same latency away from each other, but not in the wide area where we have very big differences, right? Some nodes may be, I don't know, 20 milliseconds away, and some pair of nodes may be 100 milliseconds away. And this is actually what creates all these jagged figures, right? Why the latencies that they have, 20% of the latencies are, let's say, 60 milliseconds, and the other 20% are 80 milliseconds, and so on and so forth. That is based on where the coordinator is trying to request this read, and how big of a quorum the system needs to get, and where the closest nodes for this quorum. So in a wide area network, if you can, for example, skip the hop from a client to a leader of EPaxos by just doing the direct read in ABD, initiate the read in any region, that will win you on tail latency, and that's what the evaluation is trying to show.
Okay, so I had something in the discussion, but I guess that's not a very long discussion question. So the question is, in multi-Paxos, they don't use the leader lease read optimization. Most multi-Paxos deployments use that optimization, whereas they require the leader to contact a quorum to perform the read. If they did the multi-Paxos read leases optimization at the leader, the multi-Paxos would produce the best result for the.
I wouldn't necessarily go for the best result, but it will be different. I actually think that tail latency in multi-Paxos would still be a little bit higher. So with the leader lease, you're gonna eliminate the need to run the full Paxos round, right? So essentially, you're eliminating one RTT from your system, right? At the same time, you still have the RTT from the client, which is maybe in some other region, to the leader, right? So in some cases, when you have the client and the leader collocated, your read latency is going to be very low. It's going to be local region read latency, probably under 1 millisecond or something. But then in the unfortunate event, the most unfortunate event, when you have leader in one region and the client that requesting the client who is requesting the read in the furthest away region, you're still going to be paid slightly higher latency than if that client would run the quorum from its region. So as far as the tail latency, I think Gryff and ABD protocol specifically would be better in this scenario. So someone was asking about if there is a good shared register survey paper for background context. Yeah, if someone has a good paper, please put it in a document.
Okay, Alexei, let's go through some other questions here. Question 3 we can skip, but if anybody has an application in mind, you can suggest. Binit asks why geographical location of client does not impact Gryff's read, but does impact the write. It should impact both, right?
Yes. See, if you look at the evaluation, especially with n equal to 3, the write is always going to be 2 RTTs, and the read is going to be 1 RTT most of the time, if not all the time. And that means that just the difference is more pronounced, right? Because of the geography. But there has to be an impact. Another thing is, if you look at n equal 3, there is only so many, like you only need 1 more node to get the quorum. So that's always going to be essentially the closest region to you, and you get the quorum and you perform the, you can finish the read. For the write, it's double because you have to do it at least 2 times.
Okay, so Tianyi asks, are there any other works that try to combine EPaxos and ABD before?
Not that I know of, to be honest. But I may be mistaken. This paper doesn't really cite any other works that are similar? I think it mentions 1 or 2 papers that try to do the combination of shared registers with consensus.
Okay, yeah. Alexei, let's go to the next page then to see if we can have 3 discussion groups about these discussion topics. And let's see if there is another discussion topic proposal. And then based on that, I'm going to start breakout rooms. There are 3 co-hosts. I think I can put one of us into each group. So if needed, we can share and writing on the Google Docs, and everybody will be unmuted, and groups can have easier discussion. So the first one is, I think in one discussion group with 4 or 5 people, we can see how this compares with Hermes. Hermes used read local, introduced a read local protocol. It also has read write operations in a key value store with some read modify writes that are best effort, but maybe best effort read modify writes is not that bad of an idea, because here a read modify write can also be overwritten by an ABD write. So so one group may discuss it, I guess. So that's my proposal for one thing. Another paper, another discussion breakout room could be, are there any good hybrid protocols? Because one question was ABD and EPaxos done before. Maybe a group can brainstorm about what if we, do a hybrid of this Paxos variant and this replication protocol variant, and if that solves something interesting. Maybe another, okay, so the last one is yours. What is this about?
Yeah, I'm not sure we need to discuss
application. Yeah.
We already talked about it.
I guess maybe what's a more useful application, or is this same model that people can use to develop applications in? And yeah, so everybody is free to suggest some other further discussion topic, and then I can do the breakout rooms. Okay. Any
otherwise, oh, my headphone battery died. So I'll just do the breakout rooms. I will start 3. I think we are like 15 people. I will put each of us into one room, and you can use the Google Docs to take notes when collaborating, and the breakout rooms will be better. Introduce yourself in the breakout room, and we can all start maybe working on this for 20 minutes or so. Then I will get everybody together again for the breakout rooms to report on their summary of the discussion. So everybody we can all learn from what's going on in other breakout rooms. Okay, number of rooms, 3. And I want to do this automatically. I will just do this automatically. But then I can switch users if you tell me to, okay? Okay, so we will do, I guess, summaries from the breakout sessions. Let's start with group one. What did the group one work on? Or what did you guys talk? And we can also see the Google Docs for this. Oh, everyone is muted again. Hold on. Unmute all. Okay, everybody's unmuted now. Can we have someone to speak for Google group one?
Which one was group one? Who was in that? I don't remember what group I was in.
Alexei was there. Alexei and Alex Miller and myself. But both of them had to drop off. So yeah.
Can you give us a synopsis of what you guys discussed? Any interesting thing that came up?
Yeah, so basically like how Hermes is doing linearizability is what I was asking Alex. So they are talking about multiple chains, and it also looks like it's a multiple, it can have multiple leaders. So whoever initiates it becomes the leader of the chain, and then the right will propagate along the chain. So it looks like there will be a timestamp attached to it. That's how it can be linearizable. Yeah, I didn't follow the complete discussion, so yeah, maybe I'm not right person to represent that group.
Yeah, Hermes is pretty similar. I put a link to my blog summary of that. I think Hermes provides local reads, which is very good. I think Hermes does not have maybe guaranteed completion of read, modify, write operations, but maybe that's not bad, right? If it is concurrent with a write operation, maybe you want it to be read, write later, reading the recent value and modifying and updating that. And it's also distributed key value store. Okay, maybe let's go to second group.
Second group, I guess I will start briefly on the ideas, and then John can join to add more details. Basically, for a hybrid protocol, if you want to mix different consensus or ordering protocols or replication into together, I think we are majorly interested in the protocol has to know about the operation type they're working on, and also the data types, because what kind of the data types work defines what operations you need for your application. So we know EPaxos have a conflict operation type that define if you apply C1 and C2, you will end up with, if it's a conflict operation, you will end up with a different state if you apply C2 first and C1 first. That's where you need the order. And for non-conflicting, you don't need the order. There are, for ABD, for register, you will have a different operation type defined as a replace or not, because if your output of the state is solely depends on the input, then it is a completely replace operation. But if your output is also depends on input and the previous state of the data, then you have a non-replace operation, which will need a base value for you to work on. And there may be other types of operations that can be considered for the protocol when the protocol trying to order them. And also, John had a very interesting observation, or that when you have an unstable partial order of read, modify, write kind of operations that depends on the base value, they don't have to make that ordering decision right away, because a different continuous read, modify, write operation can depend on the different base value until we have to make a decision later. So basically, you will allow unstable ordering for a while and let two parallel universe going until that you have to make a global decision later in time when some condition is met. For example, if you actually, I think, John, if you want to talk, you will give a better example.
This is impressive. You guys did a lot of progress in generalizing the ideas. So yeah, John.
Oh, let me unmute you.
Okay, thanks. Yeah, so I think this is easier to sort of follow if you look at figure 3. And so let's see. So the insight here is that the consensus commands.
Can you copy paste that into the Google Docs? Maybe everybody could see if somebody, or maybe Ali, can you do that also after the meeting? If you can also write down more details, looks like you covered ground. So I will do a summary blog post. I can include that discussion.
Okay. Yeah. Should I continue with the verbal overview? Okay. So yeah, if you look at figure 3, you can see that consensus commands have a stable order under a particular base value. So for example, RMW3 is ordered directly after W2, and then RMW4 is ordered after that. But the base values, W2, W3, etc., those don't have a stable order initially, right? They can be reordered. And so, you know, if W2 and W3 were concurrent, then we could either run W2 before W3 or vice versa. I think that's explained in sort of the one-pager write-up in more detail. So sort of building off of that, you can realize that like the consensus commands, they do get reordered across their unstable ordered base values, right? So if W2 got reordered after W3, because W2 and W3 were logically concurrent, so if W2 got reordered after W3, then its consensus values also get reordered after, for example, RMW6, right? So that's, I think that's, if you start with that sort of insight that the consensus commands also get reordered, then the question is, what other kinds of consensus commands can we apply to other scenarios where this reordering is okay, right? It's clear that it's okay for when the ABD, when you've got just read write on the ABD, and then you've got the commands are read modify write. And so one of the things that we talked about was like, if you have set insertion, then your set insertion might be something that you don't impose an ordering on, basically where you're okay with unstable orderings. So you might have an empty set where you insert 5, and then concurrently with that, you might have an empty set where you insert 42. And then you might have commands that apply to elements of the set. So you might say, I'm going to apply the command that adds 6 to the set that as long as it has 5 in it. And then concurrently with that, you could run a command which inserts 43 into the other set as long as it has 42 in it. And then you can stably order those and effectively get the set with all 4 elements. But it wouldn't be safe if the command made some assumption about all the elements in the set. So if the command said something to the effect of insert 6 only if the set is equal to the singleton set with 5 in it, and then you concurrently ran a command that said insert 43 only if the set is equal to the singleton set with 42, those I don't think you can sort of reconcile those types of scenarios. And so the scope that the command operates on seems to dictate whether this sort of whether this technique, under what circumstances this technique is generalizable.
Yeah, I think that's pretty good and requires further discussion, and that's good. And for I'll just briefly talk about group 3. We looked at the applications of this. I think one application we talked was this. First of all, we acknowledge that there has been several papers recently in NSTI and ASPLOS that looks at this distributed key value read writes as a special case that do not require necessarily consensus, and would something lighter weight would work for them. So another paper is in NSTI 20, fine-grained replicated state machine replication. It's one of the papers that we will discuss in the coming weeks. So actually, I will ask everybody to check that list. I will put that in a blog post again. And if you volunteer, you can do a 20-minute discussion of the paper in the beginning of the meeting, and then we will have the same format. I think if nobody volunteers, next week I will do the warm space paper. So we talked about maybe globe spanning payment processing application as an application that might have these read writes and sometimes read modify writes. Yeah, some OLTP examples could be examples. Tianyi mentioned that globe spanning multiplayer online role-playing games may also be suitable for this kind of read write and read modify write mixed in workloads. And also Mahmoud said that fraud detection that involves probabilistic filters like Kaku and Bloom filter in multiple buckets over many continents may also be an application, because I thought this did not require very time sensitive response, but Mahmoud said that these require very time sensitive response. So that's another application. So let me see if I can launch this poll and you can fill this in before you leave. And next week, the same time, and it will be the warm space paper. I'll do a quick one-page summary of the paper posted up by the weekend. So you have time to read the summary and read the paper read the paper if you can before the discussion next week. So I had a poll. After the poll, maybe just tell me about, we can share general comments before we finish.
So it looks like we have to answer every question, huh? As in.
Oh, you do? Okay. Well, give an answer.
Yeah.
This is the first time I'm using the poll feature.
Okay.
I thought it's a good way to get feedback.
Yeah, definitely. The question, if you read the paper, so since I didn't read, it doesn't apply to me, but like I have to answer it. Yeah.
Okay. Oh, I see. So maybe I should have a opt-out option for each question if that's the case. Got it. Okay. Okay, good idea. Yeah. Okay, I'm ending the poll, and we can have general comments. Oh, you didn't see the results. I'm sharing the results with you. Wow, 90% read the paper before the reading group. That's awesome. Easy to follow, normal, hard to follow. That's a Gaussian distribution. As somebody watched the video. Video is a good way. If you read the paper, how many hours you allocated? 1, 2 hours. Okay. If you read the paper before, and how do you? Yeah, I mean, suggestions for others, maybe we can talk about it now. How do we improve this for next week? I mean, this is the first time we did it, and actually I don't have too much Zoom experience with the class. It just started very recently, and if you have suggestions on how to improve the experience for everyone. Okay, do I need to unmute people continuously for this to work, or? Any comments? Okay, anybody else? Are you guys able to unmute yourself and speak? What's going on? I'm going to get rid of this unmuted thing forever.
Yeah, I'm not sure people can unmute themselves.
I keep unmuting people, but for the next time, I will just allow people to unmute themselves. I was worried about trolls. We had a troll in the beginning, but after that,
I'm not even sure we had. I don't know who that guy was.
Yeah, I don't know. Some people derive joy in doing this, I guess.
Yeah, for me,
Okay.
I think I need to read the paper more carefully. Yeah, to have a better understanding before the presentation. Yeah, before the discussion.
Yeah, but what about the general format of this reading group?
General format?
Yeah, if there is anything that we can improve.
I think it's good because if we follow the guideline, then we can learn a lot. Yeah, if we can follow I think there's a blog that we can follow our audience and the presenters, that if they can all follow the steps, that would be very helpful.
Yeah, reading papers takes time. I think for the NSTI papers, there is videos that help. If you watch the video, it makes reading the paper easier. I mean, I have been reading papers for 20 years, but I still take more than 3 hours to read a paper. I'm slow. Yeah.
Yeah, maybe references for whatever you think are definitely prerequisites. Like in this case, ABD and EPaxos are definitely prerequisites to follow the discussion. So maybe the next paper we discuss, you guys mention what are those prerequisites as well. So maybe we will be better prepared to follow the discussion better.
And yeah, Kriti told me that chat, if we could download the chat, or maybe if we could also have the chat in a single place with the Google Doc. I think after this, I will try to have a summary blog post and reflect the important discussion points there. So that can make this available for others and us offline. And I'm going to upload, Alex and we will upload this to YouTube. The discussion would be saved and uploaded. So I guess that helps. I hope that helps for the offline things, but I like the online discussion and learn from it. Okay, any other comments before we wrap it up? Okay, so next week it's warm space. It's another paper along these lines. I think one of the authors of the warm space is right now he's at Mahesh Balakrishnan. He's at Facebook. They have the Facebook Delos system that uses these log replication ideas to build a scalable control plane for Facebook. Facebook switched to that. They built very quickly. So I think that's a relevant paper to this one and for the papers that's going to come in the next week. So if nobody else volunteers, I will do that, do the presentation for that next week. And so I'll see you next week. And due to the random, how did the breakout sessions work for you? Having 5 people in one room, that's better. So I can meet more people and better discussion. Any comments?
Yeah, I think 5 people were was okay actually. Yeah.
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 Okay, guys, then see you next time if you are interested in the next week papers. Okay. Bye-bye.
Thank you.
Thank you.
Bye.
Thank you, Alex.
Bye.